variability. Okay, we're going to look at a distribution 58, 67, 54, 25, 33, 15, and 85. We're going to find the value of x bar, which is the sample mean, which hints that these data values represent a sample, and S, the sample standard deviation. And we're going to quickly do this on the calculator using one variable statistics. We're going to compute what we get if we take x bar, the mean, and add a standard deviation. We're going to find the data values, which are these numbers right here. We're going to find which of those data values are within one standard deviation above the mean. Now, within one standard deviation above the mean, it means that simply if we look at what we get for part B here, adding one standard deviation to the mean, we're looking at how many data values fall between the mean and this number that we get here. We're going to take the mean and subtract the standard deviation, and we're going to find out how many of these data values and which of these data values fall one standard deviation below the mean. So how many of these and which of these fall between the mean and this number that we get for part D. We're going to compute x bar minus 2s, which is basically taking the mean and subtracting 2 standard deviations and taking the mean and adding 2 standard deviations. We're going to find the percent of data values that are within one standard deviation from the mean. So within one standard deviation means from one standard deviation below the mean up to one standard deviation above the mean. We're going to find out what percent of the data values are within 2 standard deviations from the mean. Within 2 standard deviation means from 2 standard deviations below to 2 standard deviations above. Okay, so let's put this data set into a list. Okay, so going to our calculator, I'm going to use L3, 58, 67, 45, 25, 33, 15, 85. Okay, running one variable statistics, stat, calc, enter. I'm going to change the list to L3. Go down to calculate, hit enter. Okay, let's take note of our mean, 48.8571. Let's round that mean to 46.86. 46.86. And our sample standard deviation, because let's remember, the problem is asking us for S, the sample standard deviation, so we're going to ignore the line that says sigma x here. S is 24.7415. Okay, so 46.86 is our mean and 24.7415 is our standard deviation. Now, the mean of a data set can be graphically represented as the center. So if we consider our data values going from smallest to largest on this horizontal line, in the very center we're going to label our mean, 46.86. Okay, instead of actually labeling data values on this horizontal line, we're going to denote each unit as a standard deviation. So to the right, one bar would indicate x bar plus a standard deviation. Okay, so we're going to calculate x bar plus 24.7415. So if you add 46.86 plus 24.7415, you could do that on your calculator, add the two numbers, that's x bar plus s, you get 71.6015. We're going to mark that at the first bar. The question that you're asked, which data values are within one standard deviation above the mean, asks you which of your data values fall between 46.86 and 71.6015. So you look at your data values and you take note of which of them fall between these two numbers. So 58 does, 67 does, that's it. 58 and 67 are the two data values that fall between 46.86 and 71.6015. So that's between the mean and one standard deviation above the mean. Then we're going to calculate the mean minus a standard deviation, and we're going to put that number right here. So we're going to take 46.86 and we're going to subtract 24.7415. 46.86 minus 24.7415. So when you calculate that, you should get 22.1185. The question asks which data values are within one standard deviation below the mean. So you look at your mean, 46.86, you look at the value that is one standard deviation below the mean. X bar minus s is going to mean below because you're subtracting a standard deviation. So 22.1185, and you decide which of your data values fall between 22.1185 and 46.86. So 45 does, 25 does, 33 does. So those three data values fall between 22.1185 and 46.86. Okay, so the mean is in the center. One standard deviation above the mean is 71.6015. One standard deviation below the mean, 22.1185. These numbers in black, 71.6015 and 22.1185, are not necessarily data values in the data set. They just are markers that represent a distance from the mean. What percent of data values are within one standard deviation above and below the mean? So within one standard deviation means plus or minus one standard deviation. So if we take x bar and we add a standard deviation and subtract a standard deviation, we have a range that goes from 22.1185 all the way to 71.6015. The data values that fall between that range are 25, 33, 45, 56, and 67. There are 5 of them, 5 of these data values. We have a total of 1, 2, 3, 4, 5, 6, 7. So when asked what percent, we take 5, the part, divided by 7, the whole, part divided by whole times 100, that's going to give us 71.43%. What percent of data values are within 2 standard deviations from the mean? So we have to take these numbers out a little bit further. We are going to subtract 2 standard deviations from x bar, and we're going to add 2 standard deviations to x bar. Now this is the same as taking 22.1185 and subtracting the standard deviation. And it's the same as taking 71.6015 and adding the standard deviation. So if you do that, you get negative -2.623 and 96.343. So again, you can take 22.1185 and subtract 24.7415. That will give you -2.623. Taking 71.6015 and adding 24.7415, you'll get 96.343. Now that's the same as taking the mean and adding two standard deviations, taking the mean and subtracting two standard deviations. What percent of data values are within two standard deviations from the mean means what percent of data values fall from -2.623 all the way up to 96.343. So you look at your data values and you decide where they all fall. You have a 15. Your 15 will fall between -2.623 and 22.1185. And the 85 falls between 71.6015 and 96.343. So all the data values, 1, 2, 3, 4, 5, 6, 7. 7 out of 7, all of them, 100%, fall within two standard deviations of the mean. So the answer to that question is 100%. If you have any questions on this, please post them in the discussion forum. I'll be able to help you work through this. This question is sometimes difficult for students.